In this video, I will show you how to use matrices to solve some real-world problems. These are systems of equations, word problems, but we will use matrices to solve them instead of substitution or elimination. And we're going to use a graphing calculator to make our lives much easier. Number 17, a package of 4 red candies and 3 blue candies cost $6.95. A package of 6 red candies and 4 blue candies costs $10. Write a system of 2 equations to try to determine the price of each type of candy. Rewrite your system as a matrix equation. Solve your system using an inverse. Show your steps. Well, first we need to define our variables. What are we supposed to find again? Determine the price of each type of candy. Okay, so I'm going to let x equal the price of red candy. And I'm going to let y equal the price of a blue candy. Did they say blue? Okay. Alright, great. We defined our variables. So, alright, I guess the sentence basically just describes the equation. So, 4 red candies. So, 4 times the price of a red candy, and then we have 3 blue candies, so plus 3 times the price of a blue candy should equal the total cost, which is $6.95. Similarly, a package of 6 red candies, so that's 6x, and 4 blue candies, so 4y, costs $10. Okay, so there's our equation. We can write this as a matrix equation in the following way. Look at those coefficients. The coefficients are 4, 3, 6, and 4. So we can make a matrix out of those coefficients. Alright, the variables are x and y, and they will go in their own matrix. And then these values on the right hand side of the equation will go in a third matrix. I will call the first matrix A. I will call the variable matrix V, and I will call the last matrix B. So what we have here is the fact that matrix A times matrix V is equal to matrix B. What we really want is to get matrix V by itself. We can do that by multiplying both sides by A inverse. Alright, A inverse and A form the identity matrix, so they basically cancel each other out. So the bottom line is that matrix V, the variable matrix, should equal A inverse times matrix B. And here's where the calculator comes in. Okay, so go into matrix mode by hitting second matrix. We need to edit, so I'm going to slide over to the edit area and edit matrix A. Alright, now matrix A is a 2 by 2 matrix, so I need to change these dimensions. And now I get to type in 4, 3, 6, 4. So 4, 3, 6, 4. Right, so quit your way out of this by hitting second mode. Go back to the matrix area again by hitting second matrix. Go back to edit, but this time we will edit matrix B. And matrix B is a 2 by 1 matrix, 2 rows, 1 column. So I need to change my dimensions. And now here I have 6.95 and 10. 6.95 and 10. Alright, quit your way out. Second mode. So, as we said, the variable matrix will equal A inverse times B. So that's what we need on the screen. So we go back to the matrix area again. This time we stay right here under names and hit enter. That's A. Hit this little X -1 superscript button. That makes this A inverse. Go back to the matrix area again. Slide down to matrix B. This is A inverse times B. Boom! 1.1 and 0.85. Okay, so these are the prices of the red candy and the blue candy. Let's just write it off to the side using a few words. Whenever you solve a word problem, it's important to have a summary statement. A red candy costs $1.10 and a blue candy costs 85 cents. Alright, don't just leave your answer like this. Make a sentence. A painter bought a total of 8 containers of paint for $146. The gallon-sized containers cost $22 each, and the quart-sized containers cost $12. Set up a matrix equation and solve to determine how many gallon-sized containers and how many quart-sized containers he purchased. So first, let's define our variables. I'm going to let x equal the number of gallon containers and y will be the number of quart containers. Okay, let's see what kind of equations can we write. He bought a total of 8 containers. So right there, that tells me an equation. That means that x plus y must equal 8 because he bought a total of 8 containers, and these are the 2 types. Okay, we have the total amount of money. Oh, and we know the cost of each type. So let's make a money equation. Okay, so the gallon ones were $22. So $22 per gallon container plus $12 per quart container should equal the total amount of money spent. So $146. So here is our equation. So we can set up a matrix equation using the coefficients. So that's going to be 1, 1, 22, 22, and 12. 1, 1, 22, 12. Okay, next comes the variable equation, x and y. And alright, these numbers on the right hand side of the equation, 8 and 146. So there's our matrix equation. Let's call this matrix A. We'll call this matrix V for variable matrix, and this will be matrix B. Now remember that matrix V should equal A inverse times matrix B. Alright, just like the last problem. So that's what we're going to use our calculator to find. So second matrix, to get yourself to the matrix area, go over to edit. We're editing matrix A. Matrix A, oh, it's still a 2 by 2 matrix, 1, 1, 22, 12. So just get down to the typing area. 1, 1, 22, 12. Okay, quit your way out. Let's clear the screen. Go back to the matrix area again. Go back to editing. Go down to matrix B. Okay, still a 2 by 1 matrix, 8 and 146. So I'm just going to get down to where I can type in 8 and 146. Alright, quit your way out, second mode. Now we need A inverse B on the calculator screen. So I'm going to do back to the matrix area, just stay right here and hit enter. I'll click this button to make it A inverse. Go back to the matrix area. Let's choose matrix B this time, and now I have A inverse B. Kabam! 5 and 3. So that means this equals 5 and 3. Alright, this is the variable matrix I just found. That tells me that x is equal to 5 and y is equal to 3. But we need to make a summary statement. So the painter bought 5-gallon sized containers and 3 quart sized containers. John has $20,000 to invest. As his financial consultant, you recommend that he invest in treasury bills that yield 5% interest. They're talking about treasury bonds. This is something different. We got bills versus bonds that yield 7%, and corporate bonds that yield 9% interest. John wants to have an annual income of $1,280, and the amount invested in treasury bills must be 2 times the amount of money invested in corporate bonds. Find the amount in each investment. First, we had to define our variables. So let's let x be the amount invested at 5%, that's your treasury bills. Y will be the amount at 7%, the treasury bonds. And z will be the amount invested at 9%, that's your corporate bonds. Okay, what kind of equations can we make? Well, he has a total of $20,000 to invest. So that gives me one equation right there. Okay, x plus y plus z must add up to $20,000. Alright, because that's the total amount he has to invest, and this is the amount that we're investing in each category. So what else? John wants to have an annual income of $1,200. This is interest. So here comes an interest equation. Well, from the treasury bills, at 5%, the interest is going to be 0.05 times the amount of money that you have in that account. The interest from the 7% account is going to be 0.07 times the amount of money in that account. And if you invest at 9%, the amount of interest you're going to get is going to be 0.09 times the amount of money in that particular account. So this should all add up to the total amount of interest, and he wants to earn $1,280 a year in interest. So we need one more equation, so I'm hunting around, and it says the amount invested in treasury bills, okay, that's the 5% one. Okay, let me try to color coordinate this. the amount invested in treasury bills must be 2 times the amount invested in corporate bonds. Okay, so the treasury bills, that's X, and the corporate bonds, that's Z. So what they are saying to me is X must be 2 times Z. All right, treasury bills 2 times corporate bonds. Okay, now for our matrix equation, we need all of our variables to be on the left side, and we need a constant over here on the right. So if I subtract 2z from both sides, this equation will become x minus 2z is equal to 0. So this is the form that we need it to be in for the matrix equation. Okay, speaking of the matrix equation, let's go ahead and write that. Looking at the coefficients, we have 1, 1, 1, 0.05, 0.07, 0.09, and 1, 0, because there's no y, -2. So this is the coefficient matrix. Alright, the variable matrix will be x, y, and z. And then we have the final matrix, 20,000, 1,280, and 0. I will call this matrix A, and I will call this matrix V, and I will call this matrix B. So if I want to find matrix V should equal A inverse times matrix B. So let's type matrix A and B into our calculator so we can do this. So second matrix, let's go edit matrix A. This is a 3 by 3 matrix, and it's 1, 1, 1. And then 0.05, 0.07, 0.09. One, 0, -2. So there's matrix A. Let's quit our way out of this, get back to the matrix area, go over to edit, this time matrix B. This is going to be a 3 by 1 matrix. Alright, 20,000. 1,280 and 0. Quit your way out of this as well. Now go back to the matrix area, hit enter for matrix A, hit this button to make it the inverse, go back to the matrix area, go down to B. Now we have A inverse B, kabam! And this is going to be the answer, 12,000, 2,000, and 6,000. Okay, this will be very wordy to write in a summary sentence, so I think I'm just going to move these numbers and like point arrows at our definitions here. So this makes it clear that he invested $12,000 in Treasury bills, $2,000 in Treasury bonds, and $600 in corporate bonds. Did I say 600? I meant 6,000. Let's do one more problem. Tickets at a particular movie theater have different rates for adults and children. On Saturday, the theater sold 4 adult tickets and 5 child tickets for $75. The next day, the theater sold 9 adult tickets and 6 children tickets for $132. What's the price for an adult ticket and the price for a child ticket? Let's let X equal the price of adult ticket, and we'll let Y equal the price of a child ticket. Okay, this is one of those problems where the sentences just write the equations. You don't really even have to think about it. Okay, they sold 4 adult tickets and 5 child tickets for a total of $75. And a different day they sold 9 adult tickets and 6 child tickets for $132. So we can easily make a matrix equation out of this. 4, 5, 9, 6 with the coefficients. X, Y for the variables, and then a third matrix, 75 and 132. Okay, this will be matrix A. I'll call this matrix V for the variable matrix, and this will be matrix B. So we have learned that well, let's just cut to the chase. We have learned that matrix V, the variable matrix, should equal A inverse times B. So let's just put A and B in our calculator so we can do this. Alright, let's start by clearing this mess out real quick. Let's go to the matrix area. Let's go over to edit, editing matrix A. A is a 2 by 2 matrix, so we'll just fix that. 4, 5, 9, 6. Quit your way out, second mode. Back to the matrix area again. Edit, this time matrix B. This is a 2 by 1 matrix. 75, 132. Quit your way out. Back to the matrix area again. Grab matrix A, make it the inverse, go back to the matrix area again. Just grab matrix B. Now we have A inverse B. Kabam! 10, 7. So matrix V equals 10 and 7, which means that X equals 10 and Y equals 7, which means that the adult ticket is $10. The child ticket is $7. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.